Bohr's atomic model. When Rutherford gave his model, there were a lot of criticism that he could not explain the stability of atom. Then there were research on spectrum. All right. After that, there was a model given by that scientist name was Neil Bohr. He gave a Bohr atomic model, and we have it over here. Bohr atomic model talks about that the energy of a particular orbit is fixed. Rutherford, what was the doubt over there? That electron will lose its energy and the orbit will become smaller, smaller, smaller. Finally, it will collapse into the nucleus. But Neil Bohr told that the energy of orbit is constant. Electron will absorb energy and it will go to a higher orbit, and it will lose energy, it will fall back to a lower orbit. The energy of orbit is fixed. All right. That is why he gave another name to the orbit, and it was called as stationary state, because the energy of orbit is stationary. Stationary means fixed. So another name for orbit was stationary state. So how many names right now you have for orbit? Orbit is the circular path in which electron revolves around the nucleus. So first name was orbit, then we called this as shell, and now we are calling it as stationary state. So stationary state, orbit or shell, all are same. If anybody says shell, you should understand it's a circular path. If anybody says orbit, it is circular path. If anybody says stationary state, then again it's the circular path in which electron is revolving around the nucleus. All right. So if we watch out here, the first orbit is this one, the second is this, third is this, fourth is this. Another name given to these orbit was, first orbit was named as K shell, second orbit was named as L shell, third orbit was M, then N. K, L, M, N, O, P, you can go ahead like this. So these were the orbit names, either alphabetically you can name them or numerically you can name them. The the first point was the energy of each orbit is constant. Electron will absorb energy and go up higher orbit, and it will lose energy, it will fall back to the lower orbit. Let's say if electron is going from first orbit and to the third orbit, how much energy it will absorb? It will absorb energy difference E3 minus E1. If it is going from first to sixth, then it will absorb E6 minus E1. How energy of an orbit is calculated, we will talk sometime later, but in this you must understand that the energy equal to energy difference is absorbed in going to a higher orbit, and when electron falls back, it emits the energy equal to the energy difference between the orbits, right? So you can watch out here, if energy is absorbed, it goes up, it falls back when energy is emitted. So energy by electron is absorbed or emitted. It is not the orbit. Orbit has its energy constant. So orbit is not going anywhere. Thus the radius of the orbit is constant. That is what Neil Bohr talked about. And another point was quantization of angular momentum. Quantization of angular momentum means, let's say this is nucleus. Around this there will be many circular paths. So which path we are going to call as orbit? So orbit is called that circular path in which angular momentum of the electron should be integral multiple of h by 2 pi. What does that mean? If angular momentum of electron equals to 1 h by 2 pi in a circular path, then the orbit will be named as first orbit. If angular momentum of the electron is named as equals to 2h by 2 pi, then the orbit number is 2. If in a circular path the angular momentum of electron is 3h by 2 pi, then that circular path will be called as orbit number 3. So what exactly he talked about was that angular momentum of a particular electron is quantized. This is known as quantization of angular momentum. That means 1h by 2 pi in first orbit, 2h by 2 pi in second orbit, 3h by 2 pi in third orbit, 4h by 2 pi in fourth orbit. So h by 2 pi in integral multiples, it is how it is. And the last point was the energy difference which we have already talked about, that energy will be absorbed equal to energy difference when going up, it will be emitted when electron is falling back. So this is it. What and if you want to know actually wavelength, if you want to know actually wavelength or the actual frequency, what you can do is put delta E equals to h nu. You will get the frequency emitted or absorbed, and put delta E equals to hc by lambda. You will get the wavelength lambda absorbed or emitted. Just remember, when electron is going in the higher orbit, it absorbs energy. When it is falling back, it emits energy. This is what Bohr model explains about. That's it.